Okay, well, if c equals 144, then it's the same equation, but c is now 144 instead of 36. And when we divide by 144 and simplify that, we get x squared over 6 squared plus y squared over 4 squared equals 1. Okay? And what does that tell us? It tells us we get another ellipse. But now if we do the ellipse to the same scale, well, if this is 3, then this would be 6. So that ellipse is going to come out to about here and over to about here. It's going to come up about this far and down about this far. And our rectangle is going to look like this. And our ellipse is going to be much bigger. Now, what does that tell us about the graph of our function in 3 dimensions? Well, if this is 36, okay, so let's just say this is the z equals 36 plane. And let's just say the ellipse then is, oh, this big in this direction, this big in this direction. Okay, so the ellipse is going to be within a rectangle here, and a rectangle sketched on this thing is going to have, well, a rectangle with sides parallel to the x and y directions is going to have sides parallel to the y direction, which will be this way, and parallel to the x direction. When we sketch it, we've got to make these sides parallel to the x-axis, right? So we have something like this. And here's our ellipse. And let's go ahead and put a pretty color in this. Okay? So here's our ellipse. So okay? So it's floating up here in space on that plane. Okay, well, now where is the plane for c equals 144? Because we've replaced z up here with 144, right? So now we're talking about points with coordinates 144. Well, 144 is 4 times. So we've got to go up here through all my writing. And we're going to have a pretty sloppy looking graph, but we're going to do it anyway. So here's z equals 144. Okay? And we're going to have to draw a plane like so. And like so. So here's our z equals 144 plane up here with all this writing all over it. Right? It's going to look like this. Okay? And our parabola, our hyperbola, is now going to be twice the dimensions in both directions. So where it's this wide here, it's going to have to be this wide here. It's going to be significantly bigger. So our axes are going to be like this, and then our semi-axis will be like this and this. Our rectangle will be like here, and our ellipse is going to be something like this. Okay? Well, that's a good start to visualizing this surface. The other thing we can say is if z is equal to 0, then, well, this can't be negative, this can't be negative, right? So they've got to both be 0. So x and y have to be 0. So the only intersection of the graph down here in the XY plane is the origin. Okay? So we're beginning to get a picture. This thing is spreading out as we go up. Okay? It spreads out to this length when we go from z equals 0 to z equals 36. It spreads out to double the length when we go up to z equals 144. Okay, and I'm not sure I doubled the length. This is actually a little too big, but you still get the idea. Okay? The question is, what could do that? What could go from a point here to this to this? What surface is this that when sliced by the z equals 36 plane gives you this slice, okay? And when you slice it by the z equals 144 plane, you get this, okay? Could be a cone, right? If you take a cone and slice it horizontally, well, you'd get a circle, but let's make it an elliptical cone, where it's wider in this direction than it isn't. Just take a regular cone and stretch it a little more in this direction than you do in this direction, and you would get ellipses, right? Okay? But it's not a cone, because if it was a cone, it would keep spreading out at the same rate. So if you go 4 times as high, it would have to be 4 times the dimensions and not twice the dimensions. Okay? It would have to be twice the dimensions of the one I drew here. Okay? It'd be much bigger up here. Okay? So what is it? Well, let's analyze a little further.